So next we have derivative of a vector function. Now let us discuss how can you define the derivative of the vector quantity. For scalars, you know how do you calculate the derivative. Suppose f is some scalar function. So in that case, how do you define the derivative? The derivative df with respect to say the variable t is defined like this: limit delta t approaches 0 and del f by del t. Now what is this? This is limit delta t approaches 0. This is the variation of the function about the point t minus f of t divided by delta t, provided this limit exists. So this was the definition for the derivative for some scalar function. Now if instead of the scalar function, if we have a vector function over here, so in that case we'll go with the same definition, and we will say if this is a vector of some single variable, right, then its derivative with respect to the variable t, this is also defined in this similar way, but instead of the scalar function we'll define it using the vector function, and its definition would be limit delta t goes to 0, the vector the function f, vector function f defined at the point t plus delta t minus the function f defined at the point t divided by delta t. So this is the derivative of the given function. So this is the definition which defines the derivative. Now you should be asking, what does this represent geometrically? So the next question here is, what does this derivative represent geometrically? So let's have a look at this one. So here, suppose the vector r, which is the vector function f of t, this is defined to be continuous single valued function. So that means it is continuous and have single values, right, at all points. So now if I define some curve to be like this, so if I define the function r is equal to f of t like this, and on this curve I am taking 2 points, one is point P, another is point Q, and from origin I am defining the distance of the point P, so this distance as the vector r, so this is my position vector, and for this position Q I am defining this vector to be r vector plus delta r vector. So now if I know these two position vectors, the position vector of P is r vector, of O of Q from O, that is a small displacement in this r, so I am defining that by r plus delta r. So according to this triangle law, which you have studied in the previous classes, right, if you join these two through a straight line, because this is an arc, right, if you join this through straight line and its direction is this, so according to triangle law, by the triangle law of vector addition, what is this? This becomes equal to the vector OP plus the vector PQ, this is equal to the vector OQ, right? So this plus this will give you this. In effect, the sum of all these taken in the same direction would result in a zero vector. So from here you can have, because the direction for this OP is r vector and we do not know what is PQ, so and what is r OQ, that is r plus delta r. So here, from here you obtain the vector PQ as delta r. So we obtain this distance as delta r. So now once you have this distance, what do we want? We want to see the change in this position vector with respect to time. So that is what we are going to observe from here. So basically, what would your delta r by delta t, what is this quantity? Because we wanted to see what is this dr by dt. For that, what is this? This is limit delta t going to 0, delta r vector divided by delta t. So we are looking for this particular quantity. And what is this quantity? This is the vector pq divided by delta t. Now suppose what we are doing here, I'm saying as delta t goes to 0, when you take the displacement or the time between these two vectors as approaching to 0, so you will observe that this point is coming closer and closer to the point P. So that means whenever your t goes to 0, you can say the point Q reaches the point P. So it is coming very close to this point P. Therefore, we can say the chord PQ. What is the chord PQ? That is a straight line joining the points P and Q. This chord will tend to the tangent at P. So suppose the tangent at P is defined like this. So a straight line which crosses this arc at exactly one point at P, right, and which is a straight line. So this is the tangent. Suppose say this is point P. So PT is the tangent corresponding to this curve at the point P. So we will say this chord, whenever this Q will move closer and closer to P, so you see the distance between PQ will eventually be this particular tangent only. So therefore, we will say chord PQ will tend to this tangent PT, and therefore limit delta t approaches 0, delta r by delta t, this becomes equal to dr by dt. Now this thing, what does it represent? This represents a vector whose direction is that of the tangent vector, the tangent line PT to the curve at the point P. So in particular, we can say that scalar variable t is the time, r is the position vector, right? Then this derivative represents the direction of the tangent at the point P. Okay, so let me give you one example so that this thing is more clear to you. So let us have a look at one question. So the question is, find the unit tangent vector at any point on the curve. So the curve is given to you, vector r, that is equal to t square minus t I cap plus 4t minus 3 j cap plus 2t square minus 8t k cap. This is given to you. You have to find the unit tangent vector at the point on this curve, at any point on this curve. So for this solution, we know how do you obtain the tangent vector. So you have to differentiate the given curve. So say this is your equation number 1, the curve defined by this position vector r. So we will find out the derivative for this particular position vector. So this would be equal to taking the derivative for this quantity. Now you know how do you take the derivative. It's simply you will perform the derivatives of the components of the unit vectors I vector, j vector and k vector. So that would simply be equal to 2t minus 1 I cap. The derivative of t square is 2t, of minus t is minus 1 I cap as such, and then 4t, its derivative is 4, derivative of 3 minus 3 is 0, so we have this, and then derivative of 2t square is 4t minus 8 into k cap. Now this is the derivative of the position vector, and this derivative will give you the direction of this derivative. dr by dt will give you the direction of tangent. So are we done? No. Here you are asked to find the unit vector in the direction of tangent vector, right? So what is the unit vector? Therefore we can say the unit vector to any point in the direction of tangent. What would be that? You will divide this vector by its magnitude. Direction of the tangent, this thing is equal to the vector 2t minus 1 I cap plus 4j cap plus 4t minus 8 k cap. So this vector, when you divide by its magnitude, how do you obtain the magnitude? Square root of this first quantity is whole square, so 2t minus 1 whole square, plus the second quantity is whole square, and then the third quantity is 4t minus 8 whole square. So when you solve this, your answer would be, this would be equal to 2t minus 1 I cap plus 4 j cap plus 4t minus 8 k cap divided by square root of 20t square minus 68t plus 81. So this is how you define the unit vector in the direction of tangent. Okay, so let me discuss one more question. It says find the angle between the tangents to the curve r vector is equal to t square I cap plus 2t j cap minus t cube k cap at the points t is equal to plus minus 1. So here you have to calculate what is the angle between the tangents. Suppose the first tangent is defined by t1, the second tangent is defined by t2. These are the two tangents, right? So how do you calculate the angle between them? So for that we will define the dot product. Now what does this dot product represents? It represents the similarity between these two vectors, right? So the vector t1 and the vector t2. So the dot product between the vector t1 dot t2, this is equal to the magnitude of the vector t1 into the magnitude of the vector t2 into cos of angle between t1 and t2, right? So in this question we will first determine what is our t1 and what is t2. So that is the tangent to this particular curve at the point t is equal to plus 1 and at the point t is equal to minus 1. So we are given r is equal to t square I cap plus 2t j cap minus t cube k cap at the point we have to determine its tangent. So first of all, let's differentiate this. So it would be 2t I cap plus 2j cap minus 3t square k cap, right? So this is the tangent, but we have to determine the tangent at the point t is equal to plus 1 and minus 1. So at t is equal to plus 1, dr by dt, this thing would be equal to 2i cap plus 2j cap minus 3k cap, right? And dr, so this is your vector t1. And what is your vector t2? This is dr by dt evaluated at the point t is equal to minus 1. So this is equal to minus 2i cap plus 2j cap minus 3k cap. So once you have these two vectors, this vector and this vector, now we have in the question, from the question we are to calculate the angle between these two vectors. So that means we have to calculate what is this theta here. So for calculating theta, we can use this formula cos theta. This is equal to the dot product between these two vectors divided by the magnitude of the first vector and the magnitude of second vector. So now that means 2i cap plus 2j cap minus 3k cap. This is the first vector, dot product with the second vector minus 2i cap plus 2j cap minus 3k cap divided by the magnitude of first, that means square root of 2 square, that is 4, plus 2 square, that is 4, plus minus 3 whole square, that is 9. And the magnitude of second, that would again be minus 2 whole square, that is 4, 2 square, that is 4, minus 3 whole square, that is 9. So how do you calculate this dot product? You simply multiply this term with this term. So, and you know, in dot product, I dot I, that is equal to 1, j dot j is equal to 1, k dot k, that is equal to 1. And if you take any other, so that means I dot j, this would be equal to j dot k, this would be equal to k dot I. So all these things are going to be equal to 0. So these are some of the rules for calculating this dot product. So when you do this, so that means you are going to multiply only the I term with the I term. So that means 2 into minus 2, that is minus 4, and then 2 into this 2, that is equal to plus 4, and then minus 3 into minus 3, that is equal to plus 9. So this divided by square root of 8 plus 9, that is square root 17 and square root 17. So this is going to be 9 divided by square root 7. So this would be 17, right? So your cos theta, that is equal to 9 upon 17. So therefore your theta is going to be cos inverse of 9 by 17. So this is the angle between the two tangents, right?